This is the information for the retake of Pre-Calculus Test 1-1 to 1-3, which is Part A of Chapter 1. So these are the things that you need to complete before you contact me. You have to watch this video and take notes on everything as you go through it. Number 2, go back in the notes and highlight the problems that are similar to the test problems. Number 3, redo the review assignment. Take your time. If you just rush through it and, copy off, it's not going to do you any good, and you will have wasted your time. So take your time and make sure that you understand the concepts. Then contact me through email or in class and let me know that you have those things completed. I have a checklist that I'll go through with you. Do that by 2:45 on November 7th, and then the actual date for retesting would be November 9th at 1:45 would be the test taking, because I want those completed by 2:45, the end of the school day, and no exceptions. We have to get used to making sure that we have things in by the deadlines that they're supposed to be in for. So at this point, again, you need to decide. Like I said before, the class is a lot of work, and if you're able to put the time in on the videos and listen to the videos, watch them, and go through all of the things that we can do, then continue with the course. But at some point, if it seems to be getting to be too much for you, remember that up until the 80% of the course is completed, you can get a W on your transcript, which means withdrawal, and does not affect your grade point average at the college level at all. So this is a big piece, and it's been on the last couple of tests, and some people have been ignoring it. So please, please show all your work and answers on numbered notebook paper, exact answers only, no rounding unless specified. Schoology has been crashing because some of you have been trying to put all of your answers into the Schoology test, and you can't do that. So do not enter any values into the test itself. If it crashes in the evening, I'm not going to be checking my email at midnight. So make sure that you are trying to get these tests done by following the rules, and we won't have any trouble, because when I have students that are not entering their values into Schoology, they're never shut out of their tests. There's never anything weird that happens with that. Now I want to add to this that as we are testing on graphing, that some of you need to consider either printing out graph paper from the black PDF file that I have on Schoology, or purchasing some graph paper, because if we're testing you on graphs, know that we talk about tests as being museum quality, and it needs to be the best work you have ever done. Some of you are losing points, especially on this test, because you didn't even bother to label your intervals. You didn't show, did I go by ones, did I go by twos, and basically you just made sketches. Sketch and graph are two different things. A sketch is, yeah, you can be a little bit sloppier with that, but not a graph. For a graph, things have to be precise, just like they are in the notes as we go through them. So, number 1, from the table below, calculate the average rate of change for glass between 2000 and 2008, then interpret what this value means. So we have this chart, and what should grab your attention is average rate of change. I've talked about that in the notes, and I've sung the little song, slope, slope, find the slope, average rate of change, y2 minus y1 over x2 minus x1. So it really is just like finding the slope. So what we have to do is realize that if we want to talk about glass between 2000 and 2008, it's these numbers right here that we care about. And what we have is a year that goes along with this. So in 2000, glass was at 0.45 pounds per person per day. And then in 2008, it was 0.30. And usually time is our x's. I'm not going to say all the time because that's not the case, but usually time is going to be our x values. So then we'd take 0.30 minus 0.45 and divide that by 2008 minus 2000. And that is negative 0.15 divided by 8, which is negative 0.01875. And I actually left that perfect, even though it's more than our 3 decimals. There were some people that rounded it. If you rounded it correctly, that was totally fine. But there's a second piece to this. And that second piece is interpret what this value means. And you could have been really general and just said something like people produced 0.01875 less glass waste each year from 2000 to 2008. Now, the reason I say you could write something really general like that is because some of you tried to use the labels. And this one had a lot of labels. And if you leave one out, then you're not saying what the chart had for information. You're giving something else. So if you wanted to use that, you definitely would have to say it's negative 0.01875 pounds per person per day of glass waste materials that went down from 2000 to 2008. So you had to be really specific. So something general was a little bit better in that instance because of all the labels. And then number 2 says solve the equation algebraically. So we have to distribute the x, and we have to move the 5 over by adding. So 2x squared minus 7x plus 5. And then we have to factor correctly. Now, pretty obviously, 2x and x in the front would give us the 2x squared. And then you use combinations of -1 and -5 until you get the one that would add to -7 in the middle. And so our two solutions here would be x equals 5/2 and x equals 1. Like so. All right, then the next one. This is also solve algebraically, and what we have to do is make sure that we have our square root isolated. So that means by itself. I would have to subtract an x from both sides, and then I could divide both sides by -1 since we have a negative on both of these. And then to get rid of square root, we would square both sides. And hopefully realize, oh, yep, that's a quadratic. I should try to factor that to solve. So I like to keep my x squared positive. I'm going to go ahead and move everything else over, and that would be by subtracting 6x and adding 9. You factor out a common monomial factor. There isn't one, but this very well may be a perfect square trinomial. So this is x squared, and this is 3 squared, and if you multiply those together and you double them, 3x doubled is 6x, and so we notice this would be x minus 3, the quantity squared. And also notice that it's set equal to 0. You can't just drop the 0 on there. That's important. Remember, we're about precision at this level, so go ahead and find those solutions, but solutions are zeros, so we have to keep that piece there. Then, we had 2 problems on the 2 days of review that were perfect fits with what we have here for the problems on the test. Joe earns 16% more than his wife Susan. Together they make $145,100. What is Joe's annual salary and what is Susan's annual salary? And set up an algebraic equation and solve. So Susan makes less. I'm going to have her be x. Joe earns 16% more than Susan, so he earns 116% of her income. So he would be 1.16x. Now together, they make $145,100. Well, this would be 2.16x, and we would divide. And x would equal $67,175.93. And this is money, so you need to round to 2 decimal places. And that's Susan's because she made less. And to find Joe's, all you have to do is take 1.16 times the $67,175.93. But because this was a rounded answer, it is best to just keep the decimal that's in your calculator and go ahead and multiply by 1.16 to get Joe's. Otherwise, you might have a rounding error. So Joe and Susan was $67,175.93. And Joe is $77,924.07. And like it says, you had to set up an algebraic equation and solve. You can't just use trial and error, guess and check at this level. We have to see the algebra. And it has to be the algebra that you've learned as you've gone through Algebra 1, Geometry, and Algebra 2. You have to use the higher level math skills that you've been taught. Number 5, there are 2 drains for a water tank. If drain A is opened, it takes about 15 hours to empty the tank. If both drain A and drain B are opened, it takes 9 hours to empty the tank. How long would it take if only drain B was opened? Set up an algebraic equation and solve. Again, just like the ones that we had in the review for you. So one job takes 15 hours plus the other, we don't know. We don't know how long it's going to take drain B. But together, we know that it takes 9 hours. And then you find the LCD, and that would be 45x, and you multiply by 45x for all 3 of the terms. And that will give you 3x plus 45 equals 5x by doing a little canceling, some reducing there. And then you'd put the x's together, so we would get a 2x equals 45 by subtracting 3x from both sides, and 22.5 is x. And finally you put that together because it said how long, and the label here was hours. I was perfectly fine with 22.5 hours. I was perfectly fine with 22 hours and 30 minutes. That 22 hours and 30 minutes was actually a little more accurate than we wanted, so that's fantastic if you went that far. All right, this one says, let's determine whether the formula determines y as a function of x, which means we want to know, is this a function? So to see that, you have to have it solved for y. Subtract 6 from both sides, and here's where you realize it's not going to happen, because if we physically write down that square root symbol, there's a plus and a minus. So every input will have 2 outputs. So this is a no. And as you work through these a lot, you start to realize, so anytime that y has an even power to it, and we're going to have to solve for y, then we're not going to be able to have a function because it'll have the plus or minus piece. And that's exactly right. All right, this one, cubed root of x. Cubed root of x only has one solution to it. That's a yes, didn't need to see anything else. For number 8, for this one, the one spot where people would be worried would be right here. And remember, you're going to use the vertical line test. And if it touches the graph in more than one spot, then it's not a function. Well, here's where the open dot becomes important. That point is not included. That one is. This is a yes. Remember, open dots mean that's not part of the solution. That's just basically a starting point. Number 9, this one has to do with understanding what those turning points are doing. So the graph depicts a person's speed y in miles per hour during a 15-minute period of driving. The graph has 2 turning points. Looks like we've got a change there and another change right there. The first turning point is the point at which the graph stops rising and starts to fall. And then the second one is when it stops falling and starts to rise. So we can see those two. Estimate and interpret the turning points. So looks like 1, 2, 3, 4, so about 6 and 48. And the other one looks like about 10 and 44. And then we have to figure out which of these matches what is happening. So you get down to D, and it says the first turning point is at approximately 6:48. This is where their speed first stops increasing and starts to decrease. Speed is going up, and then they decrease. And now they're decreasing, and they make a change to increasing. And so that's why D would be the correct answer. So you just have to figure out what that turning point is doing. It's either changing from increasing to decreasing or changing from decreasing to increasing. That's how we get a turning point. Find the domain of the given function. Well, this one has both division and a square root, so you have to think about both of those pieces. We did have some people that were only figuring out that we couldn't use -4 and 9. You cannot ignore the numerator. X plus 8 has to be greater than or equal to 0 in order for this to work, because otherwise we'll end up having imaginary solutions and we're graphing on the real number plane. So now I have to think about this in terms of the number line, and I realize walking along the number line from left to right, I'm going to get to -8 and I'm going to have solutions. But that's going to take me to -4, and now I'm going to have to jump over -4 and get back on the number line again. And I'll keep going until I hit 9, but then I have to jump over 9 and get back on the number line one more time. And that would take care of the domain of that function. So all of those pieces had to be there. You could not just ignore that numerator. Number 11, find the domain and range of the function, and this one's hint is sketch a graph first. So we sketch the graph. That means we don't have to be as precise as we normally would, but it's not too hard to be with this one, because we realize that this would be the square root of x plus 5, which means it would move 5 units, translate 5 units to the left. And then you can always think of the graph of square root. If you go 1 to the right, it's 1 up. If you go 4 to the right, it's 2 up. And if you go 9 to the right, it's 3 up. But basically we just needed this sketch. And then you want to find the domain and range so that you'll realize that the domain of f is going to be from -5 to infinity, and the range of f is going to be from 0 to infinity. Next one, graph the function and determine. Now this is important. Graph specific points. Anything that is interesting or unique to this must be shown graphically. So like I said, you can't just make sketches on this. You have to actually have intervals and make sure that you have everything listed. So graph the function and determine if it has a point of discontinuity at x equals 0. If there is a discontinuity, tell whether it's removable or non-removable. So what you had to do, because it says show tables used for graphing, is to go ahead and figure out, how do I get that in my calculator, which it didn't look like anybody had trouble doing. But also realize that x can't equal 0, because that's in the denominator. That is going to be an asymptote. And we show that. We always show asymptotes on the graph. And then you want to know what's going on to the left of the y-axis and the right. So at least 3 points is a good guide. But again, you have to show anything that's interesting or unique to this particular graph. We have not learned how to graph things like this by hand, although we certainly could just put in numbers and make tables like this. But we should expect that there's something unique to this graph, given that it mixes together hyperbolic functions and absolute value at the same time. And that really unique piece takes place right here at -4. So we graph what we have. And then we would go ahead and notice that what's really unique to this graph is that our graph hits at -4 and bounces back down. So that has to be shown, that piece right there where it hits and bounces down. There really isn't anything startling over here on the other side. Or unique, but there it is. And last but not least, our x not equaling to 0. That is as tell whether it is removable or non-removable. Does it have a point of discontinuity? Yes, it has a point of discontinuity, and that point of discontinuity is at x equals 0, and it is non-removable. It is an asymptote. So there it is. Again, when it says sketch, then you don't have to be quite so accurate. But if it says graph, yeah, you have to be. All right, determine the intervals on which the function is A, increasing, B, decreasing, and C, constant. The graph continues on to the left and right forever. So when we're talking about intervals, remember that we never use square brackets. It's always going to be the parentheses that we use for this. And this has arrows. Actually, on the test, we put those on there. There we go. And I can see that it's going to be a horizontal line, or constant, from negative infinity up to negative 3. And this had parts A, B, and C. So my constant is part C, as I'm reading the graph from left to right. Now I get to negative 3, and it starts decreasing until it gets to 2. And my decreasing was part B. So from negative 3 to 2. And then from 2 to infinity, it's increasing. Like so. So again, those intervals, make sure you're just using parentheses, and also a reminder that we use interval notation almost exclusively in pre-calculus and beyond. So there shouldn't be any set builder, there shouldn't be any inequalities when I look at your answers. Those can be steps that you take as you're working through the test, but they cannot be your final answer. Number 14, determine the boundedness of the function. So what you have to do is either on your calculator or in your brain, make a little sketch. 7 to the x plus 3 is exponential growth, and it's been moved up 3 units. So it's looking like this. And then what you have to do is figure out, well, boundedness. It's not bounded because it's not bounded above, but it is bounded below. So that would be, in this case, answer B. Those were scrambled on your test, but that would be bounded below. 15, determine any local maximum and local minimum and the value at which they occur for f of x equals x times the absolute value of the quantity 2x minus 3. So this is where you had to write a local max of whatever the y value is at x equals whatever the x value is. Talked about that in the notes, that's important because the focus is on the y value. It's where's that highest point, where's that lowest point. And then there must have been some slips of the fingers because I did see some goofy answers here on this one. Local max of 1.125 at x equals 0.750. And then a local min of, I'm going to come back to that one in a second, at x equals 1.500. Now the reason that I skipped that one is because if you find that, usually what's going to happen for that local min is that it's going to give you scientific notation, and it's going to give you a number and say e to the negative 7th, e to the negative 9th. Now what that means is you have to put a bunch of zeros in front of it before you actually get to the number. And if it's to the 7th, then we've got 1, 2, 3, 4, 5, 6 zeros before we begin to write a number. And rounding that to 3 decimal places, that will be 0. So watch for that e to the. That's your scientific notation piece on there. Then number 16, determine algebraically whether the function is even, odd, or neither even nor odd. And you find that out by finding f of negative x and seeing what you get. So you put a negative x in and you simplify. But negative x squared is just going to be x squared. And you realize you're right back to the beginning. So f of x equals f of negative x. And that means this is even, because that's what even functions do for behavior, the reflection over the y-axis. Number 17, we're going to find all of those points of discontinuity and say whether or not they are vertical asymptotes or if they are holes. And we do that by factoring So once I factored, I realized, well, nothing's going to cancel. So that means I don't have any holes. Holes come from canceling. So what I'm going to have are vertical asymptotes, and they're going to be at x equals plus or minus 3. And it is an equals. We're not talking domain here. There were some people that put the slash through that, and you can't do that. This is the vertical asymptotes are at x equals positive 3 and negative 3 because those are the zeros of our denominator. Number 18, this one asks about horizontal asymptotes. So for horizontal asymptotes, what we do is we put infinity in for the x's. And then we take off any numbers that really aren't relevant because they're spitting in the ocean. And that would be subtracting 3 from 4 infinity squared. That's spitting in the ocean. Infinity is huge, so we don't need that minus 3 to tell us any information. And then we realize, well, we could cancel infinity squared with infinity squared, and that would leave us with 2. And that is going to be our horizontal asymptote. So horizontal asymptote at y equals 2. And it is a line, so you have to say y equals 2. You can't just say 2. You have to give the whole equation. And then number 19 says graph the function. Give equations for any asymptotes and show them on the graph. And it said graph the function, which means you're going to make tables and you're going to be accurate. You're going to have your intervals labeled. And there were some of you that did a great job on that, even though it wasn't on graph paper. You know, you had your little intervals and you labeled them 1, 2, 3, 4, 5, etc. But there were also some of you that you just ignored it altogether, and you can't do that at this level. This is about precision, so you have to make sure that you have your intervals on there, that you've labeled them. Are you going by 1s? Are you going by 2s? What are you doing? And put all of that good information on there, because this is about the algebra behind it. So with this one, we notice that, again, we can factor the denominator there. And so my vertical asymptotes come from that denominator, x equals plus or minus 3. My horizontal asymptotes come from thinking about infinity and realizing that minus 9 is spitting in the ocean. Infinity squared and infinity squared will cancel out, and we'll be left with y equals 3. And those have to be put on your graph. At this level of math, you don't just ignore it and say, oh, well, I won't put any of that on there. That's why we found those, was because they're really useful. So you make dashed or dotted lines for asymptotes. Solid lines in math are reserved for final answers. This is not our final answer. These are helper lines. So you put those on there. And then you grab the calculator and you put in, again, enough numbers so that you can see anything that's significant. And try to get out to the edges of the graph. And in this case, that would be getting to, what do we have here? 8, in all directions. And there are 3 separated parts of this graph thanks to our vertical asymptotes. So you really should have 3 little tables. And again, all of this you'll get from the calculator, so it's not like this is going to take a lot of time. But what it shows is that you can be precise enough with your math to get an accurate graph. All right, so off to the left here, we have -4 and 6.857, -5, 4.688, -6, and -4. And you cannot allow your graphs to cross your asymptotes. -2 is -2.4. And I'm just graphing using symmetry for this portion because we can see that with the numbers from the table. You want to make it look like you're approaching those asymptotes, but you're never crossing them. Crossing them is a huge no-no. That's what asymptotes tell us. At least the vertical ones. Remember that the horizontal in the middle of the graph can actually be crossed, because horizontal asymptotes are for behavior as we go to the right and left forever. So again, accuracy, incredibly important. And like I said, if you don't have graph paper, be a good idea to pick some up. Good idea to print off a sheet of graph paper from the black file folder that I have in Schoology, and then you'll be ready. All right, this one says match the function with the graph. And when you look at it, you should be thinking, okay, that's got to be one of those square root graphs. Let's see. Right here, -4 and -5. That would be where my new starting place is. So that would mean it's going to look like x plus 4 and then a -5 in the back. And that, of course, is answer C. Hoping I didn't skip one here. Alrighty, identify which of the 12 basic functions listed below fit the description given. So, like I had mentioned in the lesson, we're giving you all of the 12 basic functions, but you have to know what's going on with them, and you have to understand the language. So these are the 3 functions that are even, and to be even, that means they have to be reflected over the y-axis perfectly. So you think back to them, and you can go through the list if you need to. That's not y equals x, it is y equals x squared, and you just keep going and you realize our big V of the parent function absolute value will work. And then the one you probably weren't as familiar with, and that's cosine, because remember, cosine x starts at the point 0, 1, so it does reflect over that y-axis. And then 22 says the 2 functions that have n behavior, that as you go to the left forever, they are increasing. So again, you have to think back through all of those, and actually you thought of them while you were looking at number 21, because 2 of the 3 come from your answer to number 21. Y equals x squared, our parabolas go up to the left forever, and y equals the absolute value of x. Those are the only 2 that have that property. And then this is graph the function on your calculator to determine the domain and the range of the graph, because this one again talked about at great length about how there's that hidden behavior on the calculator, and so you had to know that this graph was translated 4 units to the left and looks like this, in order to figure out that domain and range. So the domain of G would be from -4 to infinity, not including -4, because that would be an asymptote. And then the range of G would be from -infinity to infinity, because that is going down and up forever. Graph the function on your calculator in order to answer the following questions. On what interval is the function A increasing, B decreasing, C odd, even, neither, functions extrema, find the horizontal asymptotes, and how does the graph relate to the graph of the 12 basic functions? So first things first, you had to graph it. And you didn't necessarily have to have a graphing calculator for this one if you thought through what's happening here. There's a negative in front of the x, so that would mean that this has been reflected over the y-axis. And we've got a +4, which means it's been translated up 4 units. So it's going to look something like that, with our translating up 4 units being our asymptote here. And now, this again, as I had talked about in the lesson, you don't want to leave any of these blank, because then I don't have any way of knowing, did you forget to write something down, or do you believe that it doesn't exist? So for A, when is it increasing? It's not. There never is an interval where it's increasing. It decreases from -infinity to infinity. As you read this from right to left, it starts high and it goes low. And then for C, it's not even and it's not odd, so it's neither. It does not reflect over the y-axis, and it is not a 180-degree rotation about the origin. And then for D, we have give its extrema, doesn't have any. We don't have any turning points, so that needs to be a none. Find the horizontal asymptotes, if any. That was the y equals 4. And then finally, how does that graph relate to the graph of one of the 12 basic functions? That's describing those transformations that I went through with you when I said we really could graph this one by hand. So it is the parent, y equals e to the x, reflected over the y-axis, and that's because the negative is attached to the x, and translated 4 units up. So how does the graph relate? Means describe those transformations. And then we had the two piecewise at the end here. So for the piecewise, again, what you want to do is remember that only part of the graph is used for each one of these expressions that we see up here. So when x is less than 0, we are supposed to use x cubed minus 2. Probably the easiest thing to do with this would just be to plug in some numbers and find out what's going on. Now, I want to aim at x equals 0. So sometimes you can even put that in and then say, okay, well, I have to make an open dot here. But if I put 0 in here, it's going to be at -2. And again, I'm going to put a star by that so that I know, hey, that's going to be an open dot, because that did not have an equals bar. And then I would go ahead and put in a -1 and a -2 and get -3 and -10. So at 0, -2, that's where I have to have my open dot, and then -1, -3, and -2, -10. So it's going this direction forever. Over on the other side, when x is greater than or equal to 0, we have the square root of x plus 1. So I can definitely put a 0 in there. I also want to put in other numbers that have that perfect square root, so 0, 1, and 4 would be good, and 9 would also fit on this graph, so that would be another good one to do. So at 0 we would get 1, and at 1 we would get 2, at 4 we would get 3, and at 9 we would get 4. All right, so putting those numbers on, we've got 0, 1, and that needs to be a closed dot, 1, 2, 4, 3, and 9, 4. So there is number 25. And again, to be accurate, to actually graph, you need graph paper, you need intervals, you need things labeled as you go through there. Anything else is not acceptable at this level. X squared minus 9 for x less than -1. Again, you might want to put -1 on here and just put a star by it so that you remember I'm aiming at -1. I'm not necessarily putting that in there. Or just start at -2. So -2, -5, -3, 0, -4, 7. And then think about putting that -1 in there and getting -8, because that'll help you complete that portion of the graph that you need to have on there. So if we were to put that -1 in there, we'd have -1 squared is 1, and 1 minus 9 is -8. So that needs to be an open dot, and then the graph goes up forever as we go to the left. Middle portion of the graph says that we're supposed to graph 1 if we're between -1 and 1, and that has the equals bars, so they need to be closed dots. So between -1 and 1, we're going to go up here and we're going to graph 1, y equals 1, and we'd put closed dots on either end of that. And then the absolute value of x plus 2 if x is greater than 1. Again, you could put a 1 in there knowing that that's just to aim, so 1, 3. But then we want some things as we go to the right forever. So maybe 2, 3, and 4. Absolute value of 2 is 2, plus 2 is 4. Absolute value of 3 is 3, plus 2 is 5. Absolute value of 4 is 4, plus 2 is 6. Or you could use the fact that the slope of the right side of this absolute value graph is going to be 1. So you go up 1 and over 1. So there's my 1, 3 with an open dot. Oh, it's going to have to make that huge in order for it to look like an open dot. These markers are big. And then up 1 and over 1. So again, especially with things like piecewise or any of the graphs really that we're going to do in the future, they're involved graphs at the pre-calculus level. Graph paper, or make your nice intervals, make sure you're labeling your nice intervals, and make sure that it's something that can be seen once you take a picture, because that's how I have to grade your test in the current situation. All right, so one more time. You've watched this, you've written everything down, because that's the only way I'm going to know that that's been taken care of. Take notes of all of that. Study this, go back in your notes, highlight problems that are similar to these problems, and then redo that review assignment with a focus on the things that you had wrong on the test that you know you were struggling with. For some of you it was the graphing. And then contact me, and we'll talk about when I can open up that test for you if you have everything completed. So that is the retake video for Chapter 1, Sections 1-1 to 1-3.